Hi, and welcome to the course Machine Learning. In this very first video lecture, I'm going to answer some fundamental questions about machine learning. What is machine learning and why do we use it? When the most people hear the word machine learning, they either picture a robot, a dependable butler, or a deadly terminator, depending who you're asking from. But the truth is, machine learning is not just a futuristic fantasy, it's already here. In fact, it has been around for decades in some specialized applications, such as optical character recognition, or as we know it, OCR. But the very first machine learning application that really became mainstream, which improved the lives of many 100 million people, happened way back in 1990s, and it was the spam filtering. I mean, it is not as complicated as we have it today, but it does technically qualify as machine learning. And it has actually learned so well that you very rarely need to flag an email as a spam anymore. Of course, it was not the end of it, and it was followed by hundreds of machine learning applications that now quietly power hundreds of products and features that you use regularly. It is from better recommendations to voice search to Google search, many different places. So, where does machine learning start and where does it end? How do we categorize things as a machine learning application or not a machine learning application? And what exactly does it mean for a machine to learn something? For example, if I download a copy of Wikipedia and has it on my computer, doesn't mean that my computer has really learned something because it has stored some knowledge. Uh, or is it suddenly smarter? In this video, I will start by clarifying what machine learning is and why you may want to use it. And let's start by answering the question what machine learning is. Uh, there are different sayings and different interpretations of the definition of machine learning, and here you see two definitions from two famous scientists. Uh, well, one can say machine learning is a science and, of course, art of programming computers so they can learn from data. And if you want some more general definition here, I give you some. Arthur Samuel believes that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And if you'd like one more engineering oriented, I can give you the one by Tom Mitchell. A computer program is set to learn from experience E with respect to some specific task T and some performance measure P. If it performs on T as measured by P, improves with experience E. So this is a bit more technical, but at the end it boils down what I said at the beginning. Machine learning is really the science of programming computers so they can learn from data. To give you an example, I can give you the example of spam filtering. Filtering is a machine learning program that can learn to flag a spam given some example of spam emails. For example, they could be flagged by users. And an example of regular, which means non-spam emails. The examples that the system uses to learn are called a training set, and each training example is called a training instance or sample or example. And in this case, task T is to flagging the spam for new emails. Experience E is training data, and the performance measure P needs to be defined. For example, it can be said it could be the ratio of correctly classified emails. And answering the question that we asked a couple of slides earlier, if you just download a copy of Wikipedia, your computer has a lot more data, but it's not suddenly better at anything task. So we can conclude that this is not machine learning. And don't worry for now about the terms that I used, like training, testing, performance measure. We're going to cover all these things later throughout the course, but for now, just let's hear the story of machine learning in a sense. So this was somehow a general definition of machine learning. So if I want to put it more concretely, more scientifically in a sense, I can define it as such that I'm going to give you now. Machine learning is a subfield of computer science that is concerned with building algorithms, which, to be useful, of course, rely on collection of examples of some phenomenon. These examples can come from nature, be handcrafted by humans, or generated by another algorithm. So, machine learning can be defined as the process of solving a practical problem by one, gathering a data set, and two, algorithmically building a statistical model based on the data set. And this statistical model is assumed to be used somehow to solve the practical problem that you have in hand. So we know now what machine learning is. The next question we would like to answer is why do we need to use machine learning? So this is what we're going to answer in the second part of this video lecture. Why use machine learning? Let's get back to the example of spam filtering the emails, for example. And this could be seen as a traditional programming problem. First, you would look at what a spam typically look like. You might notice that some words or phrases such as for you with the letter for and capital U, credit card, free, amazing, tend to come up a lot in the subject. So we assume that if an email has these words in its title, subject line, then potentially it's a spam. And perhaps you would also notice a few other patterns in the sender's name, email's body, and so on. So this is the first part. We study the problem. Then we are going to write a detection algorithm. This is in middle, this red one, pink one. Detection algorithm for each pattern that we noticed. And then the program would flag emails as a spam if the number of these patterns are detected. Then we are going to evaluate, to test our program and repeat step 1 and 2 until it is good enough. And since, of course, it's not a trivial problem, it is very likely that the program will become a long list of complex rules, which honestly could be pretty hard to maintain. So this was the traditional engineering approach to solve this problem. Now let's look at the machine learning approach, how machine learning will learn to solve this problem. So in contrast to what you already saw, a spam filter based on machine learning techniques automatically learns which words and phrases are good predicators of a spam by detecting unusually frequent patterns of words in the spam examples compared to the healthy ones. The program is much shorter and easier to maintain and most likely more accurate. For example, if the spammers notice that all the emails containing for you with letter number 4 instead of writing letters 4 are blocked, they might start writing for you with letters instead. And a spam filter using traditional programming techniques would need to be updated to flag for you emails. If spammers keep working around your spam filter, you will need to keep writing new rules forever. In contrast, a spam filter based on machine learning technique automatically notices that for you has become unusually frequent in the spam flagged by users, and then it starts flagging them without your intervention. So the good thing now you can see it's not only that it removes the burden of writing long list of rules to identify the spam emails. It can also help you identify the newly come trends and then filter the spam emails automatically. This is uh, by saying that, I mean you don't need to update your code manually. This is what machine learning does. It's going to learn it. And another area which machine learning, I mean, is great for that, are the problems that are too complex for traditional approaches or have no known algorithms. And an example of that is speech recognition, for example. Say you want to start simple and write a program capable of distinguishing only between the words one and two. And you might notice that word two starts with a high pitch sound t, so you could hard code an algorithm that measures hard pitch sound intensity and then use it to distinguish one and two. Easy. Obviously, this technique will not scale to thousands of words spoken by millions of very different people in noisy environment, dozen languages. So the best solution, at least this is what we have today, is to write an algorithm that learns by itself, given many examples of recording for each word. So this is one of the places that machine learning comes in to save the day. And finally, machine learning can help humans learn. Machine learning algorithms can be inspected to see what they have learned. And I know that there are so many machine learning algorithms are not that easy to interpret. We typically say they have black boxes, but for those that we can. For instance, once the spam filter has been trained on enough spam, it can easily be inspected to reveal the list of words and combinations of words that it believes are the best predicators of spams. And sometimes it really will reveal unsuspected correlations that nobody have thought about it before. So in that sense, learning algorithms could be useful in giving us, the users, the human users, insights that we didn't know exist, the knowledge that we didn't know that we need to look at. It's really giving us a new perspective. And this is a cool thing. It gives us something that is not immediately apparent to us. We also call this technique data mining. So if I want to summarize what I said on the usefulness of machine learning, I could say it as such that machine learning is great for, well, first, the problems for which existing solutions require a lot of hand tuning or long lists of rules. One machine learning algorithm can often simplify code and perform better. Second, it is great for the complex problems for which there is no good solutions at all using a traditional approach. It is like what we discussed just a couple of slides back on a speech recognition. Uh, and it's also good for fluctuating environments. Uh, the possibility of easily adapting to the new data is one of the strong points of machine learning methods. So it basically leaves the burden of automating things and updating things and tuning things from our human user's shoulder to the machine. And as I said already in the previous slides, it's very good for giving us insights about the complex problems and large amount of data that we cannot really do it by naked eyes. So that was the end of this video about machine learning as a concept. What is it and when and why we are using it? And next video, I'm going to go in a bit more details on different types of learning algorithms. So bye for now. See you in next video.